just conducting the event from my mobile. My students are over here. So we didn't have any other option than doing this. So today we got late again, and also technically it's not that resolving, so that's why I'm live on Facebook through my mobile itself. Let's hope we'll go for some hours and we'll learn together. And so is it visible? I hope. The subject today is more concept. Okay. So the subject today is more concept. And now what we will do, we will learn the concept, this chemistry subject, this subject from this chemistry. People say that this is very tough subject and they don't understand. And in my time also it was a very difficult thing for me to understand. But now I have made it very easy for you all. So we will be discussing on this topic, and I hope right now I am visible to you all, and thus my board is also. So I need this raised pane. Okay. So I hope it's visible to all of you. Now we have written more concept. Clear? So this more concept when we speak about, prior to that we should know about the atomic mass, what is an atom, what is a molecule, and some very basic of it. Okay. So the most important thing that when we speak of a mole concept, when we speak about this content of chemistry itself, we should know what an atom is and about its calculation of mass. Then we will be discussing, I will be adding one thing more, that is how to calculate the molecular mass of some compounds or maybe molecules, something kind of thing. So then we'll go to the mole concept. Clear? So now coming to this mole concept, let's start with what is an atom. Okay. So coming to the element. So I hope in my previous class I have discussed that when we are speaking of chemistry, so chemistry is all about the study of matters, their chemical abilities, their chemical reactivities, and all these are. So now I am discussing a very basic thing of chemistry, that is when we speak of matter or substance. Matter or substance. It is divided into two kinds. One is a mixture, okay, and the second one is a pure substance. So again the mixture is divided into two types, that is homogeneous, okay, and the second one is heterogeneous. Then pure substances are divided into two kinds. One is an element and the second one is a compound. Clear? And the second one is a compound. So when we study of this, so basically on this earth surface, everything which is abundant, which is available that we see nowadays, okay, with our lives, with on this earth surface, everything is composed of these elements, and pure substances are must. Okay, so whatever we see around us is a matter, and again as I discussed, it's a mixture and a pure substance. Then mixture means it's more than than two kind of things, they are mixed together. Okay, more than two kinds of matters or substances are mixed together. So then these are called mixture. So mixture is of two kinds, of homogeneous and the heterogeneous. When we speak about a homogeneous matter, so see, I am giving a very brief idea about the atoms, because I will be coming to the mole, molecule and many things. So prior to that I should give a very basic concept of the chemistry itself. That's why I am discussing this all. Okay. When we speak of a homogeneous solution, mixture, so it is something where two or more substances or matters, they are equally mixed in a ratio. So that when we take, when we distribute the samples, when we take 10 samples, 20 samples, samples of it, the ratio of both the substances mixed together will be equal in each and every sample, and that too, the whole mixture also. The example is, I am giving you, suppose I am taking the sugar in water. When I am mixing, so it's homogeneously means it is equally mixed. It is equally mixed. So the dilution or the mixture of or the solution, it contains equal ratio of sugar and water molecules at each and every part of the mixture. Clear? Suppose I am giving a spoon to you, to some of my students, to Sayanj, I am giving to Anshuman, Shubham, Soumya, then Prithviraj, then Abhishek, then Pratitosh. I am giving one scoop or one spoon each. This guy is present right now with me in the class. So each and every guy with their spoon, they will be having equal ratio of water and sugar molecules. That too, the rest which is left to me also will be having the same ratio. So that means it is evenly or equally mixed throughout. Homogeneously it is mixed. So that's why we call it a okay. Oh, that's the game. Clear. So now I would ask Reenu madam if she is available, she has to be present over here. Okay, to help me, and the students are studying that one. So again, let's resume. When I spoke about the homogeneous mixture, so it's all about a mixture which is when two or more substances, they are mixed equally together, okay, in a ratio, so that each and every part of it has the same ratio to the whole solution. Then we call it a homogeneous mixture. Then coming to the heterogeneous, I give an example of water and salt or water and sugar itself. So these are some homogeneous solutions or homogeneous mixture examples. Now coming to heterogeneous, so I can give you an example of sand. Okay, so a palm full of sand, suppose I am giving 10 samples. This is crispy. Sorry. That's a dialogue actually, Sayan, okay, he has it, so he has the patent, the copyright of it, and that dialogue is crispy. Okay, that's crispy. So I know today we are facing many problems in the video itself, but still I love, because my guys are enjoying my students, and I hope also the people in front of me or those who are watching the live session, they will enjoy, because this class is very crispy. Okay, so now we are coming to this heterogeneous solution. when we speak of heterogeneous solution, so when I am giving 100 grams of sand to each and every people, okay, if I give 100 grams of sand to each and every people, all these guys with me, again I am taking their names, Abhishek, Prithviraj, Soumya, Saiyam, Chanchuma, Shubham and Devitosh. These guys are present right now. I am equally distributing 100 grams of what? Sand to each and every guy. So here, the number of sand particles, pebbles, quartz or those which are mixed with sand, they won't be equal in numbers or amount with each and every guide, because each and every sample left with each and every student will be of different. They won't be having, if we meticulously calculate the number of sand crystals, pebbles and quartz and might be sometimes gobar also, so dry gobar. So if we go through and we check, so that they will be different. So they are not equally or homogeneously mixed. Suppose this shell we are eating as snacks, I am giving the same 50 grams to each and everybody. Okay, so though the amount is same, but the number of particles, maybe badam particles, maybe dal particles, maybe all the particles, those which comprise the mixture, won't be equal or same. So it is heterogeneous, means differently mixed, they are not equally mixed. And you just see, in the first case, the properties also changed. In first case, in case of homogeneous mixture, the salt, the sugar, they lost their solidity or the solid, they will be diluted and they will be mixed with water. So their crystalline nature will be lost. And water, neutral taste will be lost and it will be sweet or salty. So the property changes. Here, if you taste each and every particle, they will be having their own taste. Okay, now the property of the individual substances, they are not changed. Neither they are equally mixed nor their properties are changed. But in this case, they are evenly and equally mixed together and having the change in their properties to some extent. Now, while coming to these pure substances, now here when I speak of element. Element is the purest form of everything. So, whatever we see means everything is composed of elements. Everything, whether it is a plastic, whether it is this whiteboard, whether it is the lining of this whiteboard, it's a metal, and you can see the glass, you can see this aluminium, everything. These are either composed of some compounds, means the elements must be there. Okay, so what is an element? An element is the purest form of any matter or substances. So element is again divided into two types, that is a metal and the second one is a non-metal. Okay, non-metal. Example is, if I am giving you let's say hydrogen, fluorine. Okay, so these are some non-metals I'm writing over here. Okay, fluorine or let's say carbon. Okay, so these are some elements, and in metals we can write iron, we can write aurum. Okay, so we can write aluminium. So these are all the purest forms of metals. Clear? Now, so what is a compound? Now we learned about element, the purest form of substance. Okay. Now coming to compound, compounds are these are the molecules which are composed of elements in a definite ratio. molecules which are composed of elements with a definite ratio. So when I speak about it, a definite ratio, okay, so that means suppose I am giving you hydrogen and oxygen together, they mixed in a ratio of 2:1 and they form water. Clear? Now water is a compound. Now this is one molecule of water itself. Clear? Now let's say carbon dioxide. So it is 1:2 ratio. 1 carbon to 2 oxygens. Okay. Then in the same platform C, H2O is there, then H2O2 is there. This is the ratio is 2:1 and here the ratio is 2:2. Okay, and this is water and this is hydrogen peroxide. Clear? So we would die if we consume this, and we cannot live without consuming this. The difference is this. What happened? No, the ratio only changed. We have taken one more atom of oxygen here. That's how it changes. So when we speak of a compound, when the atoms of elements combine together in a definite ratio, they comprise together or they combine together in a definite ratio to form a molecule of a compound. Whether it is carbon monoxide, you say CO, this is 1:1. Now the same carbon dioxide, 1:2. The toxicity of carbon monoxide is much more than carbon dioxide. Okay, so these are all. So why I told you, I discussed all about this. What's the reason behind it? Because I had to come to this element. I have to come to this element. So when I speak of an element, okay, so sometimes I need to do like this. So when I speak of an element, so each and every element, it is composed of atoms. It is composed of atoms. Now, one molecule of an element, when broken, we find one atom. So we can say that atoms comprise together to find the molecule of an element. Atoms comprise together, means combine together to find a molecule. Suppose I'll say, let me take an example of hydrogen. Two hydrogens together they combine to form molecule of hydrogen, while one hydrogen itself is an atom. Okay, now I hope all of you must be getting me, finding me, listening to me. If you couldn't listen what understand properly, so it's a request to all of you to visit our website www.thekoutilya.com. Okay, and you can give us a call at 1-800-890-3760, or to personally contact me and to clear your doubts. Okay, that's the Koutilya's website. You can go there and you can visit the website. You can meet to us and you can come to us, and we can have a face-to-face doubt clearing session. Right now my guys are with me, so they are doing the same. Okay, this is probably for the third time they are attending this class. Okay, now still it's crispy. So this subject is so nice. Now we can say that we'll be learning many, some more things I'll be discussing with my guys today itself. Okay, so when I'm writing an element, so as I discussed, it is an element has an atom. So what is element? It is the purest form of any substance or matter. Okay, and either it is a metal or non-metal, and now it is composed of atoms. Clear? So Now each and every atom, it has a nucleus. It has a nucleus. Clear? So atom has a nucleus, and in its nucleus it has neutrons and protons. It has neutrons and protons. Sometimes we can write it small n also. Clear? So, and the electrons, they used to revolve, they used to move, rotate around their orbits, okay, rotate in their orbits around the nucleus. So here is a K shape, here is an L shape, here is an M shape, okay. These are all the shapes. I know all of you must be having some idea that 2 electrons, okay, and then 8 electrons, okay, and so on. This is how an atom is composed of. Clear? So here, in the nucleus, it is mandatory mostly for elements. They will be having equal number of neutrons and protons. So they have equal number of neutrons and protons, and that too electrons too. Clear? So they have equal number of neutrons, protons and electrons. Now I am taking an isotope of a carbon. What? Isotope? It's a new subject, a new topic, or something new word for my guys probably, or you know it. That's great. So when I am talking about isotope, okay. So what is an isotope?
Same, sir. Isotopes are elements which have the same atomic number but different mass number.
Different atomic masses and same atomic number. Is it?
Yes, sir.
Tell me, Shubha, what is an isotope? They will be having different atomic masses, but numbers will be same. Atomic numbers will be same. Like carbon is having atomic number 6. Okay, and the atomic mass it is having 12, 13, and 14. Okay, so these are the isotopes. But the standard form of carbon that we see, that is C12. That is C12. Okay, and its isotopes are having also C13 and C14. Clear? Now, in this calculation of atomic mass, mostly the number of carbon 12 isotope is taken as an example. Okay, I am taking C12 or carbon as an example of it. Clear? Now coming to this very crispy subject, so topic itself, and here I say when a carbon we take, it's having 6 number of neutrons, clear, plus 6 number of protons, is that clear, plus 6 number of electrons, clear, 6 number of electrons. That's crispy. So now we are having, see, 6 number of neutrons, 6 number of protons and 6 number of electrons. Then what's the reason why it is C12? Because
Sir, it is because the mass of the electron is very less compared to neutrons and protons. That's why we do not add their mass.
Today science is in form, so
because high watt is used.
Okay, that's great. So science tells that the number of electrons, the mass of the electrons is very negligible. It's very small, and that is 9.1 into 10 to the power minus 27. Okay, so the mass of electron, now taking the mass of neutrons and protons. They are almost equal. Okay, and that's 1.67 into 10 to the power minus 24. Clear? So in some books you will find 1.66. They are written. So it's a very small number. So the mass of the neutrons and protons are this. Okay. And when you calculate the mass of electron, okay, it is 1 by 1837 of mass of proton or neutron. So this is so negligible. Sixth number of this means 9.17 into 10 to the power minus 27. This is the mass of an electron. Sixth number of this will not happen or will not matter at all. Clear? So they are in their grams. The unit must be followed. Clear? So now, when the mass of the electron is very small, it is negligible. Means it is scale. Because somewhere it is adjusted in between these two masses. Clear? So that's why always in calculating the atomic mass, we always take the number of neutrons and the number of protons, the mass of number of neutrons and protons. So that's how it is C12. Clear? Okay. So now coming to the calculation. Now I am calculating the mass of one atom of carbon. I am calculating the mass of one atom of carbon. So when I am calculating one mass of one atom of carbon, so I know that 12 number of neutrons and protons are there. Means 6 neutrons and 6 protons. Pakka? So now this is number 12. This is multiplied with the mass of each atom, that is 1.67 into 10 to the power minus 24. Am I right? Guys? Okay. So this is what we are having. This is what we are having for equals to mass of one carbon atom. Okay. Clear? So sometimes we speak it as take it as this atomic mass unit. Okay, AMU. And sometimes we use U, unified mass. Okay, sometimes we use U as unified mass. We can say this. So, this atomic mass unit equals to one mass of one carbon atom. Then one atomic mass unit equals to 1 by 12 of what? Mass of one carbon atom. Clear? So this is the formula for one AMU. This is the formula for one AMU. Clear? 1 AMU equals to 1 AMU equals to 1 by 12 of mass of one carbon atom. Clear? Yes. Understood? Yes. So here I am getting some crispy issues. So right now let's have some fun with our learning. Clear? It's visible to all of you, I hope. Now we are having The mass of one carbon atom is 12 into this. Okay. So it comes around this 12. Because this portion when calculated, it becomes that 12. Okay. So that's why, so 12 AMU we can say. So now 1 AMU equals to 1 by 12 mass of one carbon atom. Clear? Question? Be connected. Okay. So it's like I'm feeling like some what ads are coming. So that's how I'm getting some intervals. Okay. Live again with you all. So we have calculated till one mass of what? Hello. Am I visible? Okay. That's visible. So we have calculated till carbon. What is the mass of one carbon atom and what is one AMU? So one atomic mass unit equals to 1 by 12 of one mass of carbon of C12 atom. Okay, I mentioned. Clear? Now, so we knew about the atomic mass. Now coming to the molecular mass. We knew about carbon is having 12 and oxygen is having 16. So these are U's or AMUs, these are all about the atomic mass. Now coming to the molecular mass. So let's calculate what is the molecular mass of oxygen. Shubham? What is the molecular mass of oxygen? 32 by 32 AMU. Pakka? Because one atom of oxygen has 16 AMU as mass equals to 16 AMU. Then two atoms equals to one molecule of oxygen equals to 16 into 2, that is 32 AMU atomic mass. Clear? Similarly, I am giving you some examples. I am giving some questions. Write the molecular mass of carbon dioxide. What will be the molecular mass of carbon dioxide? What will be?
44 gram. Sir, 44 AMU. 44 AMU.
44.
Yes, sir.
Let's find A, carbon dioxide, B, water, and C, let's take methane. Now, let us calculate the molecular mass of this. Calculate it. So here we can say, in first case, one carbon atom with two oxygen atoms.
Sir, completed.
In here, two hydrogen atoms with one oxygen atom. Here one carbon atom with four hydrogen atoms. Clear?
Yes, sir.
So now let me take this methane. One carbon atom is 12 into 1 Okay, I am picking this methane. Plus one hydrogen atom. One hydrogen atom. It has how much? One hydrogen atom has one atomic mass into 4 hydrogen numbers. So that means 12 plus 4 equals to 16 AU. Clear? Methane has 16 AU. Because one atom of hydrogen, it has one AU atom. Then 4 hydrogens has 4 AU and this is 12, so this is 16. Clear? Now we learned about methane. This way we can do water, do for water. This will be 16 plus 2, 18. Clear? Now coming to 32 plus 12. This will be 44. So now here we calculated the molecular mass. Okay. Now coming to the mole concept, the real mole concept. So when we speak of mole, so it is Mr. Avogadro. Okay. Who has given Mr. Avogadro? He is one of the most favorite scientists of my student Soumya. He loves Avogadro and Pythagoras a lot. Okay, so they are two crispy scientists. Okay, Avogadro and Pythagoras. So here now, Mr. Like, see, I am giving an example. If I say 1 dozen of eggs, so now we say 12 numbers of eggs. Clear? If I say 1 dozen of bananas, so it is 12 numbers. If I say 1 dozen of sugar, okay, so we can't find. So, hello?
Yes, sir.
So, when I am saying 1 dozen of sugar, so we can get 12 crystals of sugar itself that can comprise 1 dozen of sugar. But sugar as a measurement of grams or kilograms. Okay, so when we speak of why did I tell 1 dozen, when I say 1 dozen of eggs or 1 dozen of bananas, so it is simply a number of 12. It is simply a number of 12. Similarly, okay, no, I am live, I know that. Okay, I am alive. So, am I audible and I am live on Facebook? Because I am having some issues with my system, I don't know what has happened to it. But I am freezed in a frame. So, okay, let's catch. Again, so Mr. Avogadro, he had given a number, and he had given a number that is called 1 mole, like 1 dozen. He said 1 mole equals to 6.022 into 10 to the power how much? 23. Okay, so this is the number of Avogadro. So Avogadro has given a number which we call 1 mole. Like 12 is a number which we call 1 dozen. So he has given 1 mole equals to 6.022 into 10 to the power 23. Clear? Question? Now let us calculate. So 1 mole of carbon. 1 mole of carbon. Clear? Let us calculate 1 mole of carbon. So now we have to 1 mole of carbon means 12 into 1.67 into 10 to the power minus 24. This is the mass of one carbon atom into 1 mole. 1 mole means that is 6.022 into 10 to the power 23. Clear? Am I writing in the range, within the range? I hope. Clear? So this is what 12, because there is some latency, it happens because of this broadcast system. So that's why immediately it is not real time. That's why I'm not getting the response. Okay.
Someone is put some message. Is it correct? Pritam.
Screen is not clear.
No. This one. Pritam.
It is into. Correct.
That's it.
Someone has given this. So here I have written this. So it is the same.
Name is Preeti Space.
Okay, that's great that you are attending. Okay. So when you are writing this, okay, this means you are writing this multiplication itself. I hope you understand.
Computer language, factorial multiplication.
So I hope you understand this. Okay, that's great with this. So 1 mole of carbon atom, when I say this is the mass of one carbon atom into 6.022 into 10 to the power 23. Okay. Now this part, it becomes something around 1. So it will be 12 gram. It comes around 12 gram. So that is what about Shubham says, like yes, like this. Okay. And yes, in our village we say yes like this. So we call this 1 mole of carbon atom equals to 12 grams. Clear? This is all about the mole concept. If I ask you for 1 mole of oxygen, then we can find the same way, that is 16 grams. Okay, so this is how the mole concept is, and this is what the mole concept is. Now we have to thank Mr. Avogadro for his crispy number, and he has given this number to us, and this is how we find. Clear? This is how we find what will be and so we call this as molar mass or gram atomic mass. Gram atomic mass. Molar mass or gram atomic mass. Okay, so this is what the mole concept is, and with this I am closing this topic. So yes, I am signing off for the today itself. So we had a nice interaction session. Here we learned something, and I hope very shortly I'll be coming with a new subject, and that subject will be on mathematics, and I'll be coming with the chain and product rule. So it's a subject of mathematics, though it's going to help you in physics. So in 11th we are not having this subject. So I'll be live on this Sunday itself with chain rule, product rule, limits and derivatives, some mild concepts of these all, and we will meet soon. And I hope all of you have enjoyed this session. But always remember that the Koutilya doesn't have any other branch. Okay, some people, they are using Koutilya. I don't know why and how, but I salute them, I love them, I thank them. They are shining our name itself. Okay, I thank them to all. You go on like this duplicacy and piracy. So this is a very welcomable thing. I know that you understand legally. But it is the original brand is the Koutilya, and chairman is Dr. Devitosh, Acharya, I myself. Okay, and we are having our campus at plot number 46, InfoCity Avenue, Patia, Bhubaneswar 24. We are having our head office at West Vinod Nagar, Block B, Parpatganj, New Delhi, 110092. Okay, please do visit our website www.thekoutilya.com, thekoutilya.com, and you can call us at 1-800-890-3760 for any inquiries and admissions. We are taking admissions for standard 11, and also we are taking admissions for NEET and JEE, mains and advanced. So I hope you all have enjoyed today itself, and I welcome you all again, and we'll be meeting again this Sunday with the subject of calculus. Okay, so we call it a mathematics for physics. Mathematics for physics. We will be discussing some minor concepts of limits and derivatives, the chain rule and the product rule. Okay, and I hope if we can, we have made Facebook a learning platform. I hope those who are watching me, those students who are really following us, and they should come and join the Koutilya, and so that they can learn directly offline from us or online from us. It's an exclusively they can have a live interaction. So God bless you. It was a tough evening. Technologically we faced issues and many problems have been there, but still we made it, and we completed the topic, and next time I'll be coming with mathematics. The subject is the mathematics and physics together, so that's it. Stay connected to me.